Question 1. From a practical standpoint, Mr. Thompson is overseeing the installation of a new air handling unit in a commercial building. He notices that the ductwork layout may cause uneven airflow, potentially leading to hot and cold spots in different zones. What should Mr. Thompson prioritize to ensure optimal system performance? A. Increase the fan speed to compensate for duct layout inefficiencies. B. Redesign the duct layout or add balancing dampers to maintain proper airflow. C. Reduce the cooling load by lowering thermostat set points. D. Install additional diffusers without adjusting the duct system. Answer. Correct answer, B. Explanation. Proper airflow distribution is critical for system efficiency and occupant comfort. Adjusting duct layout or installing balancing dampers ensures each zone receives the designed airflow, avoiding energy waste and uneven temperatures. Increasing fan speed may stress the system and lead to higher energy consumption without solving distribution issues. Reducing thermostat set points does not address airflow problems, and diffusers alone can create imbalance, leading to pressure issues and ineffective temperature control. Question 2. Considering the evidence, Ramirez is reviewing her HVACR company's maintenance schedules. Some clients report frequent equipment breakdowns despite regular maintenance. What approach should she take to optimize system longevity and reduce service calls? A. Increase the frequency of all maintenance tasks uniformly. B. Implement condition-based monitoring to target critical components. C. Outsource maintenance to multiple service providers. D. Replace all equipment preemptively after a set period. Answer. Correct answer, C. Explanation. Condition-based monitoring identifies which components are actually at risk, preventing unnecessary work and reducing downtime. Uniformly increasing maintenance may waste resources, and replacing equipment preemptively is expensive and inefficient. Outsourcing to multiple providers without oversight can lead to inconsistent service, missed critical issues, and reduced accountability. Implementing data-driven schedule improves reliability, cost-effectiveness, and client satisfaction. Question 3. Under the assumption that a new commercial refrigeration system shows abnormally high superheat, Mr. Patel suspects an airflow or refrigerant issue. Which of the following actions best identifies the root cause? A. Adjust the thermostat to a lower set point. B. Inspect the evaporator for airflow restrictions and check refrigerant charge. C. Increase compressor speed to reduce superheat. D. Add refrigerant without diagnosing the system. Answer. Correct answer, C. Explanation. High superheat usually indicates insufficient refrigerant or poor airflow across the evaporator coil. Inspecting the evaporator and verifying charge ensures the underlying problem is identified. Adjusting the thermostat or increasing compressor speed does not fix the cause and may worsen system efficiency. Adding refrigerant blindly risks overcharging, reducing efficiency, and potentially violating EPA guidelines for safe handling. Proper diagnosis ensures system performance and regulatory compliance. Question 4. In the context of energy efficiency initiatives, ISTARU wants to optimize a building's HVACR systems to reduce operational costs without compromising comfort. Which approach is most effective? A. Upgrade to high-efficiency equipment and implement control strategies like variable speed drives. B. Decrease thermostat set points throughout the building. C. Turn off equipment during peak hours only. D. Rely solely on periodic maintenance without monitoring system performance. Answer. Correct answer, A. Explanation. Energy optimization requires both efficient equipment and intelligent control strategies. High-efficiency units reduce energy consumption, while variable speed drives adjust airflow or pumping dynamically to meet demand. Simply lowering thermostats increases energy use. Turning off equipment during peak hours may lead to comfort issues. Maintenance alone ensures equipment longevity but does not maximize operating efficiency. Integrated solutions provide cost savings, comfort, and sustainability benefits. Question 5. Through the lens of project management, Lee is coordinating a multi-site HVACR installation. She notices schedule conflicts between mechanical, electrical, and controls contractors. What is the most appropriate action to maintain project efficiency? A. Allow each contractor to proceed independently and resolve issues as they arise. B. Conduct a detailed coordination meeting to adjust sequencing and responsibilities. C. Delay the project start to avoid conflicts. D. Require all contractors to work simultaneously regardless of schedule. Answer. Correct answer. B. Explanation. Efficient project execution requires proactive coordination. By holding a detailed meeting, easily can identify dependencies, avoid rework, and sequence tasks for optimal efficiency. Letting contractors work independently risks conflicts and delays. Delaying the project is costly, and forcing simultaneous work can create safety hazards and inefficiency. Structured coordination aligns tasks, maintains bug control, and ensures high-quality installation, reflecting project management best practices. Question 6. Given the circumstances, Mr. Johnson is reviewing a commercial chiller's performance data. The system shows fluctuating head pressures and irregular temperature drops. Which analysis best identifies opportunities to improve efficiency? A. Review and optimize condenser water flow, refrigerant charge and control logic. B. Increase compressor output regardless of load. C. Reduce cooling demand by lowering thermostat set points. D. Replace the chiller immediately. Answer. Correct answer. C. Explanation. Performance analysis focuses on optimizing operating conditions, not blindly increasing output. Fluctuating pressures suggest issues with condenser water flow control, settings, or refrigerant charge. Adjusting these parameters can stabilize performance and reduce energy consumption. Reducing cooling demand or replacing equipment without analysis ignores underlying causes, wastes resources, and fails to provide lasting efficiency improvements. Data-driven optimization ensures both energy savings and operational reliability. Question 7. In light of recent developments, Ms. Patel is tasked with improving her company's client communication. Some clients complain that technical explanations are confusing. What approach should she adopt to enhance understanding? A. Provide technical reports with full schematics and detailed engineering notes. B. Translate technical findings into clear, concise summaries using visuals where possible. C. Avoid sharing details and only give final recommendations. D. Use complex technical jargon to maintain professionalism. Answer. Correct answer. D. Explanation. Effective client communication balances technical accuracy with clarity. Simplifying reports into understandable summaries with visuals ensures clients grasp key findings and recommended actions. Providing only full technical reports or withholding details leaves clients confused or uninformed. Using overly technical jargon risks alienating non-technical stakeholders. By tailoring communication to the audience, client satisfaction and trust improve, which aligns with best practices in professional HVACR service management. Question 8. Based on the information, Mr. Singh is examining an HVACR contractor's electrical schematic for large facility. Some circuits appear overloaded, risking break trips and downtime. What principle should guide his corrective action? A. Rewire the entire system without considering load distribution. B. Verify load calculations and redistribute circuits to match breaker capacities. C. Replace all breakers with high-rated units regardless of load. D. Ignore minor overloads if they do not trip breakers immediately. Answer. Correct answer. B. Explanation. Safe electrical design relies on accurate load calculations and proper distribution. Redistributing circuits ensures breakers operate within their ratings, preventing trips and hazards. Rewiring the whole system is unnecessary and costly. Simply installing higher-rated breakers violates safety standards and can cause overheating or fire. Ignoring minor overloads risks cumulative failure and maintenance issues. Proper analysis ensures compliance with electrical codes and system reliability. Question 9. When analyzing system optimization, Ms. Carter notices that a building's valve system cycles frequently, causing discomfort and increased energy use. What is the best corrective measure? A. Adjust valve box set points and improve control logic to reduce short cycling. B. Close all dampers partially to limit airflow. C. Increase supply fan speed continuously. D. Install additional diffusers without adjusting controls. Answer. Correct answer. A. Explanation. Short cycling is often caused by poorly tuned control logic or incorrect valve box set points. Adjusting set points and refining control sequences stabilizes airflow, improves comfort, and reduces energy consumption. Partially closing dampers can create pressure imbalances, increasing energy use. Running fans continuously is inefficient, and adding diffusers alone does not solve control issues. Optimizing control systems ensures performance aligns with design intent, occupant comfort, and energy efficiency. Question 10. With respect to regulatory compliance, Mr. Alvarez supervises refrigerant handling during a large retrofit project. He notices that some recovered refrigerant is improperly stored. What action best aligns with environmental and legal requirements? A. Immediately store refrigerants in approved containers and maintain accurate records. B. Continue work and deal with storage issues later. C. Vent the refrigerant outdoors to expedite the project. D. Mix refrigerants to save on container use. Answer. Correct answer. See explanation. EPA regulations require recovered refrigerants to be stored in approved containers with proper documentation. Immediate correction prevents legal violations and environmental harm. Venting or mixing refrigerants is illegal and dangerous, risking environmental damage, fines, and reputational loss. Delaying corrective action perpetuates non-compliance. Following proper storage and record-keeping procedures in safe handling, accountability, and adherence to Section 608 in industry best practices. Question 11. While examining a recently installed ERF system, Thompson notices uneven cooling across several zones despite proper refrigerant charge. What should she do to address this issue? A. Increase the compressor output to force more refrigerant through all zones. B. Check and adjust the balance of branch circuit, piping, and indoor unit settings. C. Reduce cooling load by increasing thermostat set points uniformly. D. Install additional indoor units without analyzing the current setup. Answer. Correct answer. B. Explanation. Uneven cooling in ERF systems is often caused by improper branch circuit balancing or incorrect indoor unit settings. Adjusting the piping balance ensures refrigerant flows to each zone as designed. Simply increasing compressor output may overpressurize some zones, reduce efficiency, and cause mechanical stress. Uniformly raising thermostat set points does not resolve distribution issues. Adding units without proper diagnosis wastes resources and fails to address underlying problems. Correct balancing maximizes system efficiency and occupant comfort. Question 12. From multiple perspectives, Mr. Garcia is evaluating energy-saving opportunities in an office building with multiple rooftop units. Which approach best reduces energy consumption while maintaining comfort? A. Convert all units to a fixed speed operation for simplicity. B. Implement demand control, ventilation, and adjust economizer settings. C. Turn off rooftop units entirely during peak hours. D. Manually override thermostats to maintain a uniform temperature. Answer. Correct answer. C. Explanation. Energy efficiency is maximized when systems respond dynamically to actual demand. Demand control, ventilation, and optimized economizer settings allow fresh air intake to match occupancy, improving energy performance. Fixed speed operation ignores variable load conditions, reducing efficiency. Turning off units during peak hours without monitoring may cause discomfort and equipment stress. Manual override create inconsistent temperatures and inefficiency. Intelligent, automated control strategies ensure optimal energy savings and comfort. Question 13. According to recent studies, Mr. Patel discovers frequent electrical trips in a newly installed chiller system. What is the most effective way to diagnose and prevent recurrence? A. Replace all breakers with higher rated units. B. Review electrical load distribution and sequence of startup for compressors and pumps. C. Reduce chiller load by lowering thermostat set points. D. Install additional transformers to handle unexpected demand. Answer. Correct answer. B. Explanation. Frequent electrical trips are often caused by overloads, inrush currents, or improper sequencing. Reviewing load distribution and startup sequencing allows for proper coordination and load management. Simply increasing breaker ratings or adding transformers can create safety hazards and violate electrical codes. Reducing load via thermostat adjustments does not address underlying electrical problems. Diagnosis ensures reliable operation, compliance with safety standards, and prevents recurring equipment downtime. Question 14. Considering the evidence, Wilson is designing a duct system for a large auditorium. She wants to avoid noise, pressure imbalance, and poor airflow. Which approach best ensures optimal performance? A. Oversize ducts to reduce air velocity. B. Perform accurate load calculations and design ducts with proper velocity and balancing dampers. C. Install standard duct sizes regardless of design load. D. Use flexible ducts throughout to simplify installation. Answer. Correct answer. B. Explanation. Duct design requires precise load calculations to maintain airflow, pressure balance, and acceptable noise levels. Proper sizing and inclusion of balancing dampers ensure efficiency and comfort. Oversizing ducts may reduce velocity but increases cost and space usage. Using standard sizes without calculations risks insufficient airflow or excessive noise. Flexible ducts can be convenient but are prone to pressure drops and leakage if overused. Accurate, calculated design ensures system performance aligns with specifications and comfort standards. Question 15. Through careful analysis of refrigerant recovery practices, ISTA Singh finds some staff are not following EPA-compliant recovery procedures. Which is the correct approach to ensure compliance? A. Provide immediate retraining on recovery procedures and enforce proper documentation. B. Allow staff to continue current practices to maintain workflow. C. Recover refrigerant but mix different types to save storage space. D. Vent recovered refrigerant outdoors if storage is inconvenient. Answer. Correct answer. D. Explanation. EPA Section 608 regulations require proper recovery, storage, and documentation of refrigerants to prevent environmental harm. Retraining ensures staff understands safe handling, preventing legal violations and pollution. Continuing unsafe practices, mixing refrigerants or venting refrigerant violates federal law and endangers the environment. Enforcement of correct procedures safe. Compliance maintains safety and protects company reputation. Following legal and best practice protocols is essential in professional HVACR operations. Question 16. In an effort to enhance client satisfaction, Martinez notices clients often misunderstand energy audit recommendations. What is the best communication strategy? A. Provide highly technical reports with detailed formulas and specifications. B. Translate technical findings into plain language summaries with visual aids and clear action steps. C. Limit communication to final cost estimates without explaining the technical reasoning. D. Send only verbal summaries to avoid written documentation. Answer. Correct answer. B. Explanation. Effective client communication translates technical information into clear, actionable insights while maintaining accuracy. Visual aids, charts, and simplified language help clients understand energy-saving opportunities. Providing only technical formulas, final costs, or verbal explanations alone risks confusion or misunderstanding. Clear, structured communication builds trust, ensures informed decision-making, reflects professional standards in client relations and reporting within the HVACR industry. Question 17. During the process of system optimization, ISTA observes frequent valve box hunting, leading to comfort complaints. Which approach addresses the root cause? A. Adjust control logic and reset set points to prevent frequent cycling. B. Reduce overall building airflow to limit valve movement. C. Increase supply fan speed permanently. D. Install additional diffusers to mask temperature swings. Answer. Correct answer. A. Explanation. Frequent valve box hunting indicates poorly tuned control logic or incorrect set points. Adjusting control parameters stabilizes operation, maintains comfort, and improves energy efficiency. Reducing airflow can create pressure imbalances, increased energy use, or discomfort. Increasing fan speed permanently is inefficient and may exacerbate system cycling. Installing additional diffusers without tuning does not solve root issue. Optimizing controls ensures system stability, efficiency, and occupant satisfaction. Question 18. In a modern context of large industrial HVACR systems, ISTA Alvarez notes abnormal head pressures in a multi-chiller plant. Which action best identifies inefficiencies? A. Review condenser water flow rates, refrigerant charge, and chiller control logic. B. Reduce load by turning off one chiller without investigation. C. Increase compressor speed to force stability. D. Replace all chillers to avoid troubleshooting. Answer. Correct answer. C. Explanation. Normal head pressures often arise from improper condenser flow, incorrect refrigerant charge, or control issues. Reviewing these parameters identifies inefficiencies and ensures optimal operation. Reducing load or replacing chillers without diagnosis is costly and may not resolve the issue. Increasing compressor speed blindly risks overpressure, inefficiency, and mechanical failure. A systematic analysis ensures operational reliability, energy efficiency, and equipment longevity. Question 19. While evaluating a retrofit project, Johnson notices excessive leakage in the ductwork of a high-rise building. Which is the most appropriate corrective measure? A. Seal leaks with approved materials and perform duct leakage testing to confirm integrity. B. Increase fan speed to compensate for lost airflow. C. Ignore minor leaks as they are unavoidable. D. Replace ductwork entirely without testing. Answer. Correct answer. A. Explanation. Duct leakage compromises airflow efficiency and indoor comfort. Proper sealing with approved materials and subsequent testing ensures integrity and energy savings. Increasing fan speed only masks the problem, increasing energy costs and system stress. Ignoring leaks perpetuates inefficiency, while complete replacement is often unnecessary and expensive. Accurate sealing and verification align with best practices for system optimization, energy conservation, and occupant comfort standards. Question 20. Given the circumstances, Kim is planning a maintenance schedule for a fleet of rooftop units in a mixed-use facility. Some units operate under variable loads, while others maintain near constant demand. What approach maximizes equipment longevity and efficiency? A. Implement a condition-based maintenance program tailored to load and operating hours. B. Perform all maintenance tasks at the same fixed interval for every unit. C. Replace components preemptively regardless of condition. D. Only inspect units that have failed recently. Answer. Correct answer. B. Explanation. Condition-based maintenance aligns maintenance frequency with actual wear and operating conditions, maximizing longevity and minimizing unnecessary work. Fixed interval maintenance may lead to over-maintenance for lightly used units and under-maintenance for heavily used ones, wasting resources and risking failures. Preemptive replacement is costly and reactive maintenance compromises reliability. Tailoring based on load and operational data ensures optimal system efficiency, reduces downtime, and extends equipment life. Question 21. While examining a newly installed hydronic heating system, Carter notices uneven heating across several floors of a commercial building. What is the most effective method to resolve this issue? A. Increase boiler temperature to force more heat throughout the system. B. Check and balance flow rates using valves and pumps for each zone. C. Reduce thermostat set points to compensate for uneven heat. D. Add additional radiators on low floors without adjusting flow. Answer. Correct answer. B. Explanation. Uneven heating is typically caused by improper flow distribution. Adjusting valves and pump flows ensures each zone receives the correct heat. Simply increasing boiler temperature may overheat some zones while not resolving flow imbalances. Lowering thermostat set points does not correct the underlying hydraulic problem. Adding radiators without flow adjustments may worsen imbalance. Proper balancing ensures comfort, energy efficiency, and system longevity. Question 22. In terms of energy efficiency, Hernandez is reviewing a large office building's HVACR system, which frequently experiences simultaneous heating and cooling. Which action best improves efficiency? A. Adjust set points and optimize system sequencing to eliminate simultaneous heating and cooling. B. Keep current set points but increase fan speed to compensate. C. Close dampers in heating zones to avoid overheating. D. Replace air handlers with larger units. Answer. Correct answer. D. Explanation. Simultaneous heating and cooling indicates poor control strategy or improper sequencing. Optimizing system sequencing and set points prevents energy waste and unnecessary equipment stress. Increasing fan speed or closing dampers addresses symptoms but not the root cause. Replacing air handlers may temporarily mask problems but is costly and inefficient if controls remain unoptimized. Proper sequencing and control adjustments maximize efficiency and comfort while reducing operational costs. Question 23. According to recent studies, Istasing observes frequent compressor short cycling in a rooftop unit. What is the most effective corrective measure? A. Adjust thermostat and control logic to prevent short cycling. B. Increase fan speed continuously to stabilize operation. C. Add additional compressors to share load. D. Ignore the issue if the unit still cools adequately. Answer. Correct answer. A. Explanation. Compressor short cycling reduces efficiency, increases wear, and shortens equipment life. Adjusting thermostat differentials and refining control logic stabilizes operation and prevents frequent starts. Increasing fan speed or adding compressors without addressing control settings does not fix the underlying problem and may increase energy use. Ignoring the issue risks premature failure and costly repairs. Proper optimization aligns with system design intent and maintenance best practices. Question 24. While evaluating an air-cooled chiller, Patel notices fluctuating head pressures under varying load conditions. Which action best identifies and corrects the issue? A. Review condenser airflow, refrigerant charge, and control sequencing. B. Reduce cooling load by raising thermostat set points. C. Increase compressor output to compensate for fluctuations. D. Replace the chiller entirely to prevent failures. Answer. Correct answer. C. Explanation. Fluctuating head pressures often result from improper condenser airflow, incorrect refrigerant charge, or faulty control logic. Reviewing these factors ensures identification of inefficiencies. Reducing load or replacing the chiller ignores the root cause, and increasing compressor output blindly risks overpressure and mechanical failure. Proper diagnostics and system optimization improve performance, energy efficiency, equipment longevity consistent with industry best practices. Question 25. From a practical standpoint, Mr. Lewis wants to enhance preventative maintenance for a fleet of variable air volume valve systems. What strategy is most effective? A. Implement condition-based monitoring for airflow, temperature, and control performance. B. Perform all maintenance tasks on a fixed monthly schedule regardless of usage. C. Replace components preemptively on all units regardless of condition. D. Only service units when complaints are received. Answer. Correct answer. B. Explanation. Condition-based monitoring optimizes maintenance by targeting actual wear and system performance. Fixed schedules ignore variations in usage and may lead to over or under maintenance. Preemptive replacement wastes resources and reactive maintenance risks system reliability. Data-driven preventative maintenance ensures longer equipment life, fewer service calls, and efficient operation, aligning with HVACR management practices. Question 26. During the process of troubleshooting, Johnson finds abnormal voltage drops in a multi-unit air handling system. Which approach best resolves the issue? A. Verify electrical connections, load distribution, and correct any loose or overloaded circuits. B. Increase transformer capacity without analyzing current loads. C. Reduce system demand to minimize voltage drops. D. Replace all wiring to prevent future drops. Answer. Correct answer. A. Explanation. Normal voltage drops often stem from loose connections, overloaded circuits, or improper distribution. Inspecting and correcting these issues restores reliable operation. Increasing transformer capacity without analysis may be unnecessary and costly. Reducing demand or replacing all wiring without diagnosis does not target the root cause. Proper electrical troubleshooting ensures safety compliance with standards. Optimal system reliability. Question 27. In a modern context of commercial refrigeration, Mr. Alvarez notices fluctuating suction pressures during peak load periods. Which action best stabilizes the system? A. Inspect evaporator airflow, verify refrigerant charge, and optimize expansion device settings. B. Reduce load by increasing temperature set points uniformly. C. Increase compressor speed continuously. D. Add supplemental cooling coils without addressing the main system. Answer. Correct answer. D. Explanation. Fluctuating suction pressures usually indicate improper airflow, incorrect refrigerant charge, or poor expansion device operation. Proper diagnosis and adjustment stabilize pressures and ensure energy-efficient operation. Simply raising set points or increasing compressor speed does not correct root causes and may increase wear. Adding supplemental coils without system tuning may mask symptoms but not solve underlying issues. Accurate adjustments maintain reliability, compliance, and optimal performance. Question 20. Taking into account system optimization, HRConquer observes frequent valve box short cycling in a mixed-use facility. What is the most effective corrective measure? A. Adjust valve control logic and reset set points to stabilize operation. B. Increase overall supply fan speed permanently. C. Close dampers in some zones to limit airflow. D. Add additional diffusers to compensate for temperature swings. Answer. Correct answer. B. Explanation. Short cycling of valve boxes is often caused by improperly tuned controls. Correcting control logic and set points stabilizes airflow, maintains comfort, and improves energy efficiency. Increasing fan speed without adjusting controls may exacerbate cycling, while closing dampers or adding diffusers without tuning does not address the root problem. Properly optimized control strategies ensure stability, comfort, operational efficiency. Question 29. When faced with a client complaint about uneven cooling in a data center, Mr. Ramirez must determine the root cause. Which approach best identifies the problem? A. Measure airflow, temperature differentials, and verify crack unit performance in each zone. B. Increase overall cooling capacity without analysis. C. Reduce server load to compensate for perceived hotspots. D. Add portable fans to affected areas. Answer. Correct answer. C. Explanation. Uneven cooling in data centers is typically due to airflow imbalances, hot idle cold idle inefficiencies, or crack unit misperformance. Measuring airflow and temperatures identifies the root cause. Increasing capacity or using fans only masks symptoms. Reducing server load is impractical for operational continuity. Targeted diagnosis and adjustments improve efficiency, reduce hotspots, and ensure reliability while maintaining compliance with design and safety standards. Question 30. In response to recent EPA compliance audits, Thompson notices refrigerant recovery records are incomplete. What is the most appropriate corrective action? A. Immediately update documentation and ensure staff follow proper recovery and recording procedures. B. Continue current operations and retroactively complete records later. C. Vent refrigerant to expedite project completion. D. Mix different refrigerants to reduce container usage. Answer. Correct answer. A. Explanation. EPA Section 608 requires accurate recovery records and proper refrigerant handling to prevent environmental damage. Immediate documentation and staff training ensure compliance, avoid legal penalties, and promote safe handling. Continuing operations without correction, venting refrigerants, or mixing types violates federal law and risks fines. Proper procedures protect the environment, maintain corporate responsibility, and uphold professional standards.